This is the last factoring technique you're going to learn, and this is factoring when a does not equal 1 and we have a trinomial. So you may or may not have noticed this, but we have been factoring trinomials quite a bit, but every trinomial we factored early on had a 1 as a leading coefficient. The problems we're going to work with today have not a 1 as a leading coefficient, and that makes factoring a lot rougher. So in the case I have right here, I have the correct answer waiting for us, and I could verify that that's a correct answer by just multiplying out the. So I'm going to do that for you. And you see that over there on the side now in fine print. When I multiplied out, I ended up with some like terms put together, but I ended up with exactly where I started out, which tells me that this is a correct answer. This is the factored form of that trinomial. The problem is you can't follow that guideline we used to follow. We used to say, what two numbers multiply to 4 and add to positive 7? That question works if the leading coefficient is a 1. If the leading coefficient is not a 1, then I've got a problem. I have to follow what I'm going to call intelligent guess and check. And intelligent guess and check is going to go this way. This term right here, the first term, is going to be corresponding with the first parts of your parentheses. So in other words, there and there. And then the last term is going to correspond to the last parts of your parentheses, there and there. So what I mean by that is, when I saw my first term was 3x squared, I knew what went here and here had to multiply to give me a 3x squared. When I saw my last term was a 4, a positive 4, I knew what went there and there had to be a positive 4 multiplied. Here's why we have a problem though. I call this intelligent guess and check because there's other forms I could have come up with that still seemed correct until I multiplied them out. Let me give you an example. What I just wrote here seems pretty darn reasonable. These two numbers multiply to give me my first term. These two numbers multiply to give me my last term. So it seems like I've done something good, but now watch what happens when I check this. When I multiply this out, I end up with 3x squared plus 8x plus 4, which is not correct. That means this attempt, although it was a good idea, does not give me a correct answer. So that means I'd try another attempt. So I have another attempt sitting there on the paper, and I'm still following the guidelines. This first term has the first terms in the parentheses multiply to equal 3x squared. My last term is a 4, so I need to choose two numbers that multiply to 4. And I've done this, but again, if I go ahead and multiply, you're going to see that my answer is not correct. So there's the fine print after I do the that make it evident that my answer is wrong. And now notice that both of these are wrong. This one looks darn close to that one. The only difference is I put the 1 in the first parentheses and the 4 in the second parentheses. So it just tells you how close you can be and still not be correct. So if I were doing this problem, this might have been my first try. Turned out I'm wrong. This might have been my second try. Turned out I'm wrong. And then maybe this would be my third try, and it turns out I'm right. This is why I call this intelligent guess and check. The intelligent part is I know what I put in my first parts of the parentheses must multiply to equal that. What I put in the last parts of my parentheses must multiply to equal that. But I still need to check it, because even if I'm following those rules, I might not be correct. So here's a case where I have a trinomial, but the leading coefficient is 2. That's not a 1. So that means I can't use that sentence that I said before, what two numbers multiply to negative 10 and add to negative 1. So I have to use intelligent guess and check. And here's how that goes. I look at the last term, and whatever I put in the last part of each parentheses has to multiply to negative 10. So I ended up choosing a negative 5 and a positive 2. My problem is it could have been a negative 10 and a positive 1, or I could have even switched the order. I could have done a plus 2 and a minus 5, but there's only one combination that works. There's even more combinations that could have happened that I didn't list. Also, I have to take a look at my original first term, and these two first parts of the parentheses have to multiply to give me that first term. So a 2x and an x multiplies to give 2x squared. So this is the factored form, the correct answer, and I prove it by doing the and it works out. But I'm going to show you the 3 things that I could have possibly tried before I arrived at the right answer. All of these 3 guesses are good guesses. They all show my first part of the parentheses multiplying to 2x squared. A negative 10 and a positive 1 multiplies to negative 10. A 10 and a negative 1 multiplies to negative 10, and so does a positive 5 and a negative 2. But all of these good guesses, when I work it out, lead to falseness. So I have to say no to all 3 of those. So what I'm really hoping is I get lucky and guess a good combination right away, or at least in the second try or third try. In this case, it could have been 4 tries before I ultimately get my correct answer. So in our final answer, or our final example, my initial term has to correspond so that inside the parentheses, the first parts multiply to give me that. So life was good there. And my final term, I have to choose 2 numbers that multiply to positive 6. In this case, be aware, a negative 6 and a negative 1 multiply to positive 6. You always have to think of the negative numbers as well as the positive numbers. So in this final example, 4x squared minus 10x plus 6, it's a trinomial, but the a does not equal 1, so I have to use intelligent guess and check. I don't get to use that nifty sentence. I show you over here what the correct final answer ends up being. 4x and x multiply to give me a 4x squared. A negative 6 and a negative 1 multiply to give me positive 6. So I have a good guess, but I don't know if it's correct until I check it. That's why we call it intelligent guess and check. My answer after I do the multiplying ends up giving me the original problem, so I know that I have a correct answer. This is the correct factored form. And in this case, I just showed you a couple of other good guesses that turn out to be false. For example, 4x and x multiply to 4x squared. These 2 numbers multiply to be positive 6, so it seems like a good guess, but turns out it's wrong. Same thing over here. These 2 multiply to 4x squared, and these 2 multiply to positive 6. Seems like a good guess, but it turns out to be wrong. So you can tell that there'd be a little bit of rough waters because you can do some really good intelligent guessing and your check still turns out to be wrong. Because these are more difficult, you wouldn't have to do a batch of like 10 or 12 of them at a time. You would only need to do about 2 or 3 problems at a time, maybe 4. All right, that good news for you is our last factoring technique that we're going to learn.